Now first scheduling algorithm can be first come, first serve. That means according to the arrival time of the processes, we are trying to schedule the processes with the CPU, right? So the process which is coming earliest will be of highest priority. So FCFS can be easily implemented using a FIFO queue. When a process enters the ready queue, its PCB is linked to the tail of the queue, right? It means, say we have something like this. This is my main memory, and in this main memory these are the processes. So this is PCB 1, PCB 3, PCB 4, PCB 5. PCB means process control block, right? So and their arrival time are 0, 1, 3 and 7, right? So the first process is PCB 1, that is P1 say, and this is my FIFO queue. I have a queue with me. So in this queue, this is the start. So at time 1, a new process P3 is submitted to the system. So it will be appended at the tail of this queue, right? So this is the front and this is tail, you can say. So you can implement this queue with the help of linked list also, right? So this is the start, and next to this process will be submitted PCB 3, and next to it will be PCB 4, and then PCB 5, right? So whenever a new process is submitted, it will be appended in the tail, right? And processes are executed starting from the start pointer, right? So this is how we can implement FCFS. So when CPU is free, it is allocated to the process at the head of the queue, that is your start. So let's have an example to understand FCFS better way. We have three processes with us, P1, P2, P3, and their burst time are 24, 3 and 3 respectively. Suppose that the processes arrive in the order P1, P2, P3. Draw the Gantt chart for this system and calculate average waiting time, average turnaround time and average response time, right? The point here to note is processes are arriving in the order P1, P2, P3 and their arrival time is not given explicitly. So we are assuming that their arrival time is almost 0. Almost 0. Say P1 has been arrived at time 0, P2 is arrived at time 0.00000001, P3 is arrived at 0.000000000001, right? So overall their arrival time is almost 0, but P1 has been arrived first, then P2 and then P3. So we know the order, right? So this can be the Gantt chart of the system. P1 has been arrived first at time 0, and its burst time means the CPU time. Burst time means CPU time, and its CPU time is 24. So P1 will be finished at 24th second. Then P2 is arriving, right? Then P2 is arriving. P2 burst time is 3 seconds. So P2 will start from 24 and it will end at 27. P3's burst time is again 3. So P3 is starting at 27 and it will finish at 30, right? So this is the overall Gantt chart of the CPU, right? You can say the timeline diagram of the CPU. So we have to find out the average waiting time, average turnaround time, and average response time. So average waiting time says that the time a process is waiting. So average wait, or we can say waiting time of P1 plus waiting time of P2 plus waiting time of P3 divided by 3 will give you the average waiting time of the system. So waiting time for P1 is 0 because it has arrived at time 0 and it got the CPU at time 0 only. So P1's waiting time is 0. P2 was also submitted at time 0, almost 0, and it is allocated the CPU at 24th second. So up to 24th second P2 has to wait. So waiting time of P2 is 24. Similarly P3 was also submitted at time almost 0 and it got the CPU at 27. So waiting time of P3 is 27 seconds and average waiting time will be 0 plus 24 plus 27 divided by 3, that is 17, right? Average turnaround time will be turnaround time of P1 plus turnaround time of P2 plus turnaround time of P3 divided by 3. So turnaround time says that the submission time and the completion time. So this difference between submission time and its completion time is called as the turnaround time of that process. So process P1 is completed at time 24th second and it was submitted at time 0. So its turnaround time is 24 minus 0 plus turnaround time of P2. So P2 finishes at 27 second and it was submitted at time 0. So 27 minus 0 is the turnaround time of process P2. Process P3 is submitted at time 0 and it completes at time 30. So 30 minus 0 is the completion time, turnaround time of process P3. So process P1 turnaround time plus process P2 turnaround time plus process P3 turnaround time divided by 3 will give you the average turnaround time, and that is 20.33. Average response time, that when a process is submitted and when it is getting the first response, right? So process P1 was submitted at time 0 and it is getting the CPU first time at time 0 only. So response time of process P1 is 0 second. Process P2 was submitted at 0 and it is getting the CPU first time at 24th second. So that of P2 will be 24. For P3, 27 minus 0, that is 27, divided by 3 is equal to 17. So this is the average response time of process, average response time of the system. right? Let's have another example. So considering example 1, that is our previous example, this one, suppose that the processes arrive in the order P2, P3 and P1. So this time their order has been changed. Again, we have not given the arrival time values, so we are considering that they are arriving at almost time 0. Draw the Gantt chart for this system and calculate average waiting time, average turnaround time and average response time. So this time Gantt chart will look like this. Process P2 burst time was 3 seconds, P3 burst time was 3 seconds and P1's burst time was 24 seconds. That is here. P1 burst time was 24, P2 and P3 was of 3 seconds each, right? And their order are P2, P3, P1. So first of all, P2 will be executed for 3 seconds, 0 to 3. Then P3 will be executed for 3 seconds, 3 to 6. And then P1 is executed for 24 seconds. So from 6 to 30, right? So waiting time for P1 will be this time 6 seconds. For P2 it is 0. For P3 it is 3. So average waiting time will be 3. Average turnaround time. So turnaround time of P1 is 30 minus 0 because it is completed at 30 seconds and it was submitted at time 0, almost 0. So 30 minus 0 plus turnaround time for process P2, that is 3 minus 0. Process P2 is completed at 3rd second and it was submitted at time 0. So 3 minus 0 plus turnaround time of P3 is 6 minus 0 and then divided by 3, it will give you 13. Average response time. So response time of process P1 is 6 seconds plus that of P2 is 0 and that of P3 is 3. So it comes out to be 3. Now if we compare the values of this problem with our previous problem, so average waiting time was 17, average turnaround time was 20.33 and average response time was 17. So 17, 20.33 and 17. In this case, we are having the processes with same burst time except that their order is changed, and because of that average waiting time comes out to be 3, which was 17 in last case, and average turnaround time comes out to be 13, which was 20.33 in last case, and average response time is equal to 3, which was again 17 in the last case. So in this case, all these 3 parameters having very less value as compared to previous example. So what we can say? What is difference between this problem and our last problem? If you look at the burst time of these processes, so this time what we have done that we have executed P2 and P3 first and their burst time was 3. So the highest burst time process P1 was executed in the last. So from here we can say that if we execute smaller processes first, the overall waiting time will be reduced, the overall turnaround time will be reduced, and overall response time will also be reduced, right? And this can be understood with the help of our day-to-day life example also. Like in malls, big bazaar, we have separate queue for those who are having only less than 5 items to bill, right? There is a separate billing counter for those who are having only say 5 products with them, 5 items. So here the same concept is applied, that processes with shorter time is executed first, then the overall waiting time, overall turnaround time, and overall response time will be minimized, and hence throughput can be increased, right? So a convoy effect says that short process behind long processes may lead to lower CPU utilization, right? So this is the convoy effect. Many times in some exam they ask that what is convoy effect, directly or indirectly. So we should have some idea about convoy effect, that what it says, right? So if shorter processes waits behind long processes, this leads to the low CPU utilization, and that is called as convoy.